In a previous lesson, we talked about compounding interest and what that really means. It means your interest is kicking in. So one time I thought, well, the more times my interest kicks in, the more money I'll get, right? Okay, fine. Let's go with that idea. First of all, let's write down that formula one more time. So A equals P, 1 plus R over N to the NT. And I'm going to pick some numbers here that are very unrealistic, but will help us get at the point of answering the question of, am I able to get an infinite amount of money? So is it possible to compound interest in an infinitely small increment and get an infinite amount of money? So we're going to do a very unreasonable bank account, and we're going to start with $1 at 100% interest for 1 year. So just in case you needed to know all the little details, here they are. P is equal to 1. R is equal to 100%, so that would be 1. And T is equal to 1. And we're just using lots of ones to make the computation easy. N, however, will not always be 1. So annually is indeed 1 time per year. Semi-annually is 2 times per year. Quarterly is 4. Monthly is 12. Daily is 360. Just 360. Banks, from my understanding, use a formula for daily interest of 360, not 365, and I don't know why that is, but anyway, so 360. Every hour for a year, now we're going to use 365 days a year, so let's actually use the correct number of days. So 365 times 24, and that's going to give me 8,760 hours in a year. That means my interest would kick in 8,760 times. Every minute for a year, so let's multiply that by 60. That would give me 525,600. And then every second for a year, that would be 31,536,000 seconds in a year, assuming it's not a leap year, because we use 365, not 366. Okay, what would you type in your calculator? Well, let's figure it out. So P is 1. 1 plus R, which is 1. N, in this case, is 1, and we're going to raise it to the 1 times 1. We can do this one in our head. 1 times 1 plus 1 to the 1 times 1. So we basically have a 1 plus 1 here, so it's just going to be 2. So here's the deal. If I have $1 I invest at 100% interest, not realistic, for 1 year, interest compounded annually, then I will get $2, or I'll have $2 at the end of the year. Okay, so if it's semi-annually, it's 1 plus 1 over 2 to the 2 times 1. And we can do this one in our head as well. 1 plus 1/2, that would be 1 1/2. We square 1 1/2, and we get 9 over 4. That's 2 1/4 multiplied by 1, so 2.25. Okay, from here on I am going to use a calculator. So 1 plus 1/4, and we raise it to the 4 times 1, and we'll get something. And 1 plus 1 over 12, and we raise it to the 12 times 1, and we'll get something. And then 1 plus 1 over 360, and we raise it to the 360 times 1, and we get something. And I'm not going to write the big numbers out from here on out. I will write the actual answers here, but not here, because we kind of see the point, and those are big numbers to have to write over and over and over again. So, all right, battery's about dead on my calculator. I've been doing a whole lot of math. Nothing wrong with that. That's 2.44140625. Now, I know you're thinking, well, we're dealing with money here, so why don't I just round to 2 decimal places? Trust me, I'm going to use all of them, and it'll kind of help if I do. So 12, and then we're going to raise that to the 12. And so 2.613033529. And then, let me show you a shortcut. Okay, this next one is 360. So 360 is going to store. I'm going to press STO. It's the store button. When I press that, this pops up, and I want to store it as something. I'm going to press alpha and N, and now N is 360. So from here on out, I could just type 1, and then 1 plus 1 over N, and we'll raise it to the N times 1. I'm going to leave off the times 1. I can leave off that 1 in the front too. I just choose not to. So I will have $2.714516025. Again, let's not lose sight of what we're actually doing. The real question is, am I able to get an infinite amount of money when I have a smaller smaller range of time frame for compounding interest. So the more I compound interest, do I get more money? Well, the answer is yes. Do I get an infinite amount of money? Well, 2, 2.25, 2.44, 2.61, 2.71. I wonder if it's going to go towards infinity. Let's keep going. We'll find out. So every hour for a year, that's 8760. I'm going to store that as N. And then let's go back up and pull up that last thing we typed that had this in it. And I'll get 2.7181266691. All right, now we're going to store that as N. Let me put the calculator somewhere where it's not in the way and there's not a glare. So let's clear that out. 525,600 stores to N. And then we'll go back up to that thing we typed, press enter, and we have 2.7182799215. Okay, so now let's start answering the question. As the number of times that interest is compounded increases, does the amount increase? Yes. Does it tend towards infinity? Looks like we're getting kind of around $2.71 or 72 cents. So I'm not feeling it. I'm not thinking we are. So let's clear this out. 31,536,000 stores as N. We'll go up to that thing we typed right there. Press enter. 2.71828247 an infinite number of times per year. I'll put an infinity there, and I'm just going to put in parentheses continuously compounded, like every infinitesimal second my interest is kicking in, which sounds like I'd get a lot of money, but I don't. I'll tell you what I get. I get $2.72. That's it. Sorry. That's all you get. The actual number, though, is, let me give you the exact number, as much as we can. It's actually rounded off. 2.7182818828. No, it does not keep repeating, actually. And this is E. It's rounded off. This is like pi. So it is named E after a mathematician that you will encounter in the next lesson. And E stands for the name of the mathematician that came up with this number that actually, you're like, oh, a guy invented a number? How practical can it be? Well, it's practical for banking formulas and a lot of other things too. So this is Euler Constant. It's pronounced Euler. It's spelled like Euler. And that is the number. And again, it's like pi. It goes on forever. It has no pattern. I know the 1828 happens like repeatedly there, but that's a coincidence. And so it doesn't keep repeating 1828. It goes on forever, and there are people that can memorize hundreds and thousands of digits of pi, and they could do the same for E if they wanted to. Okay, so when money is compounded continuously, we're going to use this formula. So in a previous lesson, we dealt with this formula when it was like annually or semi-annually or quarterly or monthly. And now we're going to use this formula. So same stuff applies, like A is the amount after time has elapsed. After time elapsed. P is the original amount. We call it the principal. Principal amount. E is Euler's constant. So 2.7182818828. R, I don't have room to put the arrows, so that's a rate. And it cannot be a percent. It has to be a decimal. And T is years. And it's exactly like what we've been doing. Okay, so let's keep going. $1,200 is placed into an account that earns 2.45% interest, compounded continuously. How much money is in the account at the end of 5 years? Well, because it says continuously, that word right there means I will not use this. I will be using this formula. So A equals P, E to the RT. How much money is in the account? I'm going to write down everything I know and find what I don't know. So my original amount is, well, 1,200. Whoops, I wrote the wrong thing. The amount I'm wanting is, well, I don't know. The original amount is 1,200. The rate is 2.45%, which is really 0.0245. And time is 5. So we're going to plug all those numbers in and figure it out. Now, lucky you, there is an E button on your calculator, so you don't have to type 2.71828.828. So 1,200 E, and you don't have to write it. You just put the letter E to the 0.0245 times 5. I'm going to put that in parentheses just to make it look neat. I'll grab my calculator that almost has a dead battery. I'll have to charge it in a second. And we'll do 1,200 E. All right, here's the buttons. Second and the LN button. We'll talk about what LN means later. 0.0245 times 5. And the answer is money, so we'll round to 2 decimal places, 1356.38. How much money is in the account at the end of 5 years? That is how much. So we're going to do a similar problem. $400 is invested into an account that earns 1.2% interest compounded continuously. If you find it necessary, you can write the stuff down that you know. I know P is 400. I know the rate is 1.2%, which is really 0.012. I know it's continuous, which means I'll use this formula, PE to the RT. How much money is in the account? Well, they're asking for the A value, and they told you 18 months. But wait, there's a trick to this one. It's not as basic as you think, and here's the trick. 18 months, well, T has to be the number of years, but they gave me months. 18 months is 1.5 years. If you're 18 months old, well, then you're probably not capable of watching this video and understanding it. But if you're 18 months old, then you've gotten a year behind you and 6 more months. 1 year, 6 months is 1.5 years. So A equals 400 E to the 0.012 times 1.5, and we'll type that in the calculator and get an answer. So 400 E to the 0.012 times 1.5. One more time, I'll tell you. E is second, and LN, and when you do it that way, it automatically pulls up the exponent that you need. And there's my battery, much better than it was a minute ago. 407.27, we're dealing with money. Okay, let's do number 3, and then when we get to number 4, things transition just a little bit. So number 3 is similar to what we just encountered. I recommend you mute the video and try this on your own. So I'm just going to start underlining important things and writing some stuff down. I probably won't even be talking much, so mute it or not. They did say years, so we'll stick with years. There we go. This lesson's off to a pretty solid start. So far we have figured out that we do not get an infinite amount of money when our interest is compounded more. We actually end up with a number about like this that shows up in the formula. This number is Euler's constant, and now we know how to use the formula.